equation called Schrodinger's equation. But it turns out that what that equation tells you is the probability that the system will be in different states, and that is unambiguously determined. But when you measure it, of course, you can't say for certain which state it's going to be in. And it is absolutely true for certain systems, but not all systems. For certain systems, you will literally, the system is in many different configurations at the same time, and when you measure it, you'll, with a certain probability, find it in one of those situations. And in the act of measurement, therefore, you'll take a system that was doing many different things and fix it to be doing one of them with a certain probability. And the observer, and by observer, I don't mean doesn't have to be a human being. It can be a measurement apparatus, an inanimate object that measures the click of a Geiger counter, say, and that will, in fact, the system after that measurement will not be the same as the system was before. It was doing many things before, and now it's in one specific configuration. It's a remarkable fact that measurement can affect the system, and does often, but not always, does often change the state of a system. And that is part of the craziness that makes quantum mechanics so fascinating. It's not completely crazy, because we understand how it works, and it doesn't allow for certain things like some New Age people seem to think that implies that if you think about the universe, you can change it outside of your body and far away, and that's just not a property of quantum mechanics. It's a property of what New Age people would like quantum mechanics to be, but it's not a property of quantum mechanics. Quantum mechanics is darn strange, even without all the nonsense.
So just to recapitulate, the chief difference between quantum physics and quantum mechanics is?
The chief difference is that classical systems are well defined. They're in a single place at a single time. It's unambiguous. They're measurable, and quantum systems cannot be so defined until after you measure them. Before you measure them, they're behaving as if they're in many places doing many different things. And not only are they behaving that way, they essentially are. So our classical notion of a world that's well defined around us on very small scales is simply not true.
All right. Well, now let me clarify what I meant a while ago by intent. Yeah, obviously, if there's an external force that, a big wind comes up, dislodges a stick, and it moves away from the rock, and the rock rolls down the hill and busts the caveman in the head. No, there's not necessarily intent there.
Oh, yeah, you don't believe that someone is blowing to make the wind happen. Okay.
Well, unless, God decided to take him out, right?
Well, if there was a God, yeah.
Well, let me ask you this now.
Mm-hmm.
Have you thoroughly investigated have you studied the Bible at all?
I've read it when I was a young person, yeah.
Well, okay, well.
I don't think let me tell you up front, and I should be honest about this, I don't think it's a document worth studying greatly. Literally, has some interesting passages, but after all, it was written mostly by, illiterate peasants who didn't know anything about the universe, and I don't take what they say too seriously.
Okay.
I don't, and it's also inconsistent with a lot of what we know about the universe. The Earth didn't stop when someone blew a horn. If it did, all of everything we now know would be destroyed. And not only that, the sun didn't stand still in the sky because the sun doesn't go around the Earth. The Earth goes around the sun. And so it's obviously a nice literary allegory for people trying to understand the world. And I understand it in that context. And it's an interesting document. It's an interesting historical document as you try and figure out the groups of people who wrote it over hundreds of years. But I think it has to be understood as a historical document.
Well, do you find that, you have chaos theory. Mm-hmm. We know these things occur. It's been defined, or let's lose that word. It's been identified. It has not necessarily been defined. Would you agree with that or not?
Well, let's see. Chaos has a mathematical definition, which is actually well defined. It's not fully to understand the properties of chaotic systems is very hard, but to define chaos is actually well defined mathematically. It's basically that a system could be in two different states that are arbitrarily close at one time, but will diverge over time in a largely random way, so they can be very, very different at later times.
Okay.
So that the classical example is a butterfly flapping its wings in Kansas produces a storm in New York City.
Well, I never really got that. I never.
Well, it's maybe not a great analogy, but it basically says small perturbations can cause systems to suddenly greatly depart from what they were doing before.
Well, I mean,
you tweak a little thing, and suddenly you make, ultimately, over time, the system will be vastly different than it was before.
You know, when you combine the idea that, yes, there are many planets out there that could support life, except we just don't see a planet like ours. Ours seems to be unique within certainly within a few thousand miles of the planet. A few million light years around the planet. Unless it's just really well concealed. And you combine that with, it just seems to me that there are so many extras. In other words, we all don't walk around like zombies eating a goo that everybody eats, and this one plant makes it, and we must find that plant that makes that goo, and so that's what we spend our time doing. You know, there are strawberries and blueberries and different color flowers and all these different species of birds and so forth, and it just, it's very difficult for me to, I don't cling to religion.
Mm-hmm.
I cling to the notion of a creator because I see too many extras. Do the extras not figure into your calculations? Or in other words, to pursue your work, do you have to separate yourself from, I don't even like the word religion. You can brush your teeth every hour on the hour, and that becomes, he brushes his teeth religiously every hour on the hour. Sometimes I think we use words, but we do not really convey our meaning.
Well, yeah, that's true. But so the question you want to ask me is, do you not find that these extras are a component which would suggest a specific design? No, I don't. I find those extras remarkable, and I'm fascinated to learn about them. And the fact that the universe is different than I might have expected, and that people are different, and that plants are different, and that other planets may behave differently, is fascinating for me. And it takes me out of my own picture that the universe was created for me, or that that everywhere is always like what I'm used to. And I guess I find, if anything, it excites me to think that there are vast differences, and that the universe in most places is hostile to my existence. It makes me feel more fortunate to exist. But it's certainly, I don't see any evidence of the need for a creator in that. In fact, the most properties of life would suggest, if there was intelligent design, that if there was design, that it wasn't very intelligent. There's redundancies in the way we see things, in the way our eyes work. I mean, you wouldn't have designed an eye like our eyes work with the cables going from the front to the back because we have a blind spot. You probably wouldn't design our reproductive systems and our plumbing to be so intimately related, or in fact that we breathe through the same pipe that we try and eat through. I mean, there's lots of design I'd do differently if I was designing from scratch. So, but I can understand all of those as evolutionary byproducts of systems. So I guess I find it even more remarkable that diversity can arise naturally. And when I look out at the universe and try and understand how that happens, I'm amazed when we can predict how that might happen, and our predictions turn out to be true. So I guess I find that nature without God is much more fascinating than just taking the simple cop-out saying we can't understand how this happened, it must have been created. I find it much more fascinating to actually ask the question, how could it have happened? And every now and then getting the right answer, which is what makes it so satisfying when you're a scientist.
Well, would you allow for the possibility that there was a creator who said, okay, this thing is in motion, I know exactly how it's going to go? Because it states in Scripture that the end is known from the beginning, which suggests to me that, okay, this domino has been pushed and the rest of the dominoes are going to fall. I'm now going to go and do something else and leave this sector of the universe to itself.
I'd certainly allow for that. I mean, the point is that science can't rule out the notion that there was some purpose to the universe, even if there's no evidence that there is now in anything we can see. But I can't rule out that the universe was created with some purpose in mind. Nor, frankly, can I rule out the possibility that there's a China teapot orbiting Jupiter. But all I can say is that the evidence of nature doesn't necessarily direct me in that direction. In fact, there's no evidence. There's no evidence of design that I can see. But the other thing I guess I would say is that even that deistic notion of a God, of a universal creator that started all in motion and then got out of the business, which is a pretty kind of impotent God, if you will. But even that,
or indifferent.
Well, I mean, sort of irrelevant. It didn't care about human activity. It certainly doesn't intervene in human activity. That even such a creator, such an intelligence, which, as I say, could exist, and science can't rule out that possibility. That's very different than the gods of the world's religions, than the angry gods, the gods that care about our existence. There's no connection, no logical connection between the possibility that the universe was created with a purpose and the gods of the different world's religions, all of whom are inconsistent with each other, by the way. And so I'm always amazed that people who feel that there is some purpose to the universe, they look out and they see the beauty of nature and they say it must be here for a reason, and that comforts them. But that's totally different than suddenly allowing for the ridiculous fairy tales that are in most of the scriptures of the world's religions, whether it's Judaism, Christianity, Islam, or whatever, or Mormonism.
Well, perhaps just the existence of the universe, perhaps its existence is its own purpose. I mean, people.
Well, that could be. That's fine. But then you don't have to write a book about. You don't have to write these fairy tales about people resurrecting or stopping or stopping the earth by blowing the horn, stopping the sun by blowing the horn. Those are all nice fairy tales, but they obviously have no connection with reality.
Well, you would admit that there are anomalies that occur once and then maybe never happen again that occur in nature.
Yeah, but maybe I'm not. I would admit that there are things that occur that are difficult to understand, and there are anomalies. The universe is a big place, so rare events happen all the time, and I certainly would occur that. I certainly would point out that there's no documented miracles of any sort. There's things we don't understand, and that doesn't mean they're miraculous. We usually understand them, but so not understanding something doesn't make something miraculous. And we like to, again, it's a similar thing when I talk to the UFO people. They see some strange lights in the sky, and they immediately jump to the presumption that they're coming from some other planet and they're alien intelligences, and that I can't say they aren't, but I can say that many more mundane explanations are more likely.
And this is where I see a contradiction that's I don't think can be avoided, and it is that it's our perception of the reaction of other people which determines what our next step is.
Mm-hmm.
I mean, just like what you said about the UFOs, it's like you see a bright light in the sky and somebody says it's got to be a UFO, and you're going, no, it's not. But if enough people are convinced that it's a UFO, then that bit of information, however false, takes on a life of its own, with cascading ramifications sometimes.
Absolutely, and I think, I think the people have studied this, the way crowds and groups behave, and how they can come to remarkable conclusions about things, and often are delusions in groups. Somehow people are deluded in groups, whether it's the belief that back in 2000 that the dot-coms would do wonderfully and then get busted, or the housing markets, or whatever. And so, there are group dynamics that produce very fascinating effects. This is an interesting area of evolutionary psychology and anthropology.
Well, if somebody was to ask me, off mic a couple of days from now, hey, what was Dr. Krauss like? I would say, I think he has less of a problem with the idea of a creator that we call God than he has with what we would call religion, which I think I really believe that religion can be an impediment to discovery. I believe Galileo went through that, and numerous other visionaries went through that very thing. Heretics, roast them at the stake, that sort of thing. But
I think religion. I'd agree with you there, but I agree with you in terms of describing me, perhaps. The one thing that I would add is my philosophical prejudice that I'd rather live in a universe without a God. But I don't have as much problem with some, as I say, some vague intelligence that got the whole thing going. But I repeat that I see no evidence for it, and therefore I don't have any need for the hypothesis, as Newton might say. But I'd certainly prefer to live in a universe that in which we're not the. Certainly, I would not want to live in a universe with a God that cared about me.
All right, I'd like to explore that further when we come back with Dr. Lawrence M. Krauss, his book, A Universe from Nothing. Please stand by. This is Coast to Coast AM. Yes, let's not think about all those things we fear. Let's just be glad to be here. And I am glad to be here with you. John B. Wells in with you on Saturday night, the second Saturday night of my whole career with Coast to Coast AM. And we're talking with Dr. Lawrence Krauss and his latest book, A Universe from Nothing. We're going to take a few of your calls, and Ross has given you the numbers and will again. And if you would like to send an email, and I can relay your question or message to Dr. Krauss, please do so at John B., John, B as in Bravo, John B. at coasttocoastam.com. We'll take a little quick break here and then have a nice long haul up to the top of the hour, so please stay with us. This is Coast to Coast AM. Dr. Krauss, well, I realize anybody can make a mistake, but I've gotten a couple of emails here that are like, now, wait a minute, how can an illiterate person write anything? So, you know what I mean?
Yep.
So be careful, because we're going to get busted on anything that you say, and they'll take it out on me because they can't get to you, so be careful.
Well, now, I'm glad at least you bear the brunt and not me.
Yeah, I'm the professor's whipping boy tonight. I don't like that, Doc. Hey, let me ask you something. Now, I'm not sure which is going to be more or less, I don't know which is going to be less discreet, the question or the potential answer.
Okay.
If you don't feel like answering it, I'll honor that and just go past. Just say, let's not deal with that, and we'll just go on. No big deal.
Okay.
How necessary is this point of view in order to get along with other scientists? Or, I mean, are they only open-minded about certain things, or is it sort of like washing your hands in the 1800s because you're afraid some invisible something is going to cause a malady of some sort that has yet to be identified as infection?
Well, look, I think that scientists are people, and they come in all different characteristics, and they have all sorts of different predilections and beliefs about themselves and the world around them. And the wonderful thing is that they don't let those get in the way of their science. So there are deeply religious scientists, and there are scientists who call themselves atheists, and all of that is irrelevant, because the world is the way it is, whether we like it or not. And as long as they don't let their personal beliefs get in the way of the work they do, then we all get along fine together. And I've shared the stage, and I've been on stage with a good friend of mine, Ken Miller, who's a deeply religious Catholic evolutionary biologist, to defend the teaching of biology in high schools to stop people who want kids to be ignorant from learning about evolution. And so, but we have very different religious beliefs, but we certainly work together. So, the notion that there's this closed group of scientists that we want everyone to agree with us but we have this, we get together and we have these secret handshakes in these meetings is not true. In fact, as I often say, when you go into work every day, the one thing you want to do is prove all your colleagues wrong, because that's the way to get famous.
Well, that makes perfect sense, actually. Now, Tracy would like to know why you would not want a God. Would you just expand on that a little bit?
Yeah. Well, I guess I wouldn't want a God that cares about me, because I guess I'm influenced by my late friend Christopher Hitchens. I don't want to be a sheep. I don't want to be, and in fact, the gods of all the scriptures are just kind of, like eternal Saddam Husseins. You do something wrong, they don't just put you in jail for a year or 10 years, but for eternity. I find a universe in which you're a puppet to be far less pleasant than a universe in which you can revel in your existence and enjoy the freedom that you have of inquiry about the universe and the mysteries. And I guess I just find a universe that that is out there to study, and the mysteries that remain to be discovered, based on your understanding and the ability of your brain to be much more fun. It's like being on an adventure. If you're on an adventure and you want to explore things, wouldn't you feel awful if you were exploring things and you thought you were finding them out on your own, but in fact someone was actually pushing buttons to tell you which way to go? And I just find it much more fun to think that I'm on my own and the universe is my oyster.
Now you realize some people could construe that to mean, well, does arrogance come into any of this? I mean,
you can call it arrogance. I like to think of it as humility. I find it incredibly arrogant to think that the whole that first of all, that I actually do find it much more arrogant to imagine that the universe cares about my existence. I find that, I think, more arrogant to assume that I somehow am so significant that the whole universe cares about my existence.
I don't know, Doctor. I think it's touching. I mean, I think it'd be amazing that the actual creator of the entire universe could take a moment out to actually care about each individual. Just as it's written in the scripture that he knows when every sparrow falls.
To each his own. If you find it touching, that's fine. I don't have any problem with it, but surely don't you think it? Well, for me, I think it represents a kind of more cosmic arrogance to think that the universal creator, if there was one, would take time out to care about me. It's touching, but incredibly arrogant, given all the billions of galaxies in the universe and the hundreds of billions of stars in each galaxy, and even the billions of people on Earth. But I don't have any problem with it. If it makes you feel happy, I certainly don't have any problem with it. But I do have a problem when people tell me that my thinking my somehow feeling that I'm not that I don't think a creator cares about me is arrogant. I think it's actually the opposite. I think I'm just not that important.
That's interesting, Doctor, because you're not challenging my faith, and I'm not really challenging yours. But it's interesting that we have, genuinely opposing views on this, and you have your reasons, and you feel strongly about them, and I have my reasons. I feel strongly about them. So to use that really worn out expression, it's all good. But I'll tell you what, one of us is going to look like a real you-know-what if at the end of the line, okay? And I don't think it's me. But that's just me.
It's a gamble I'm taking, I guess.
Yeah. Well, all right. About Hitchens. Mm-hmm. How did you happen to meet Christopher Hitchens?
Oh, that's a good question. I actually did something I probably very rarely done when the first time we met. I actually think through a friend, I wrote him an email and told him how impressed I was with something he'd written, and it turned out he'd been reading my stuff, which amazed me. Of course, he read everything, and we started to talk, and we just hit it off, and in a sense, I became his resident physicist, as we said one day. We laughed one day, shortly near the end, actually, when I was at his house. But it was really a fan letter, if you want, I suppose, the one way to put it. And I was kind of shocked that he had something nice to say about my writing, and because I was so impressed with the quality of his writing and the quality of his mind, it was a wonderful, for me, it was just a wonderful thing, because he, as I like to say, he inspired me so much when I used to visit him. I used to want to grow up and be an intellectual because he was so much more well-read than anyone I've ever known. And our conversations span widely across every possible subject.
Antony Flew was known as the world's most notorious atheist, and in the end, as an old man, he changed his mind.
Richard didn't.
Richard never did. And did he? I'm sorry, I didn't mean to cut you off. Go ahead, finish.
No, I was going to say Christopher never did, and I think that part shows part of his strength of character. He was an amazingly brave man, and he wasn't afraid of saying things that were unpopular. He wrote a great book called Advice for a Young Contrarian, and he was a contrarian till the end, and for that I'll always admire him.
Not to. This interview is about you. It's not about Christopher, but And it's too bad. That's a rough way to check out.
It is, and actually, it is, but he was, optimistic till the end. He was an optimist, and I was just at his house the other night with speaking to his widow, who's a good friend, and he was an optimist right up to the end. And you're right, but it's. I think it shows, great strength of character, and I'm very. What really made me sad was that Christopher was writing the foreword for the new book until he became too ill, and I know it would have been quite insightful. And and again, strength of character. I talked to him and I said, "Look, you could just cut it short, and put what you've done." And he said, "No, I'd rather not appear than my not being incredibly proud of it." And I think again that shows great strength of character and integrity.
Was he a happy person? I only knew him from his interviews over the radio, but he did not strike me as a happy man. Do you find that to be?
No, I think he was an incredibly happy man. He was like a kid in a candy store when it came to ideas. He was also remarkably tolerant of people and their views, which again you might not get from the interviews because people often confronted him. He had good friends who had views that were remarkably different than his, and they would have parties at the house and would spend time there. And one of his close friends is Francis Collins, who's the head of the National Institutes of Health, and as you probably know or may not know, is a scientist who's a devout, born-again Christian who's written a book on which I know Christopher disagreed on virtually everything. So he was very tolerant and surrounded himself with people not who were necessarily like-minded, but who were interesting and from whom he could learn and who were willing to talk and who were nice and yeah, he probably had a broader set of friends of more diverse. Some of them, I'm not going to go more. A lot of it's private. I don't want to go into details. But he was friends with people you would never imagine he would be friends with.
And they liked each other.
Yeah. Yeah, he and I disagree. We didn't agree on everything. We disagreed on the Iraq War, for example. But disagreements between friends are fine as long as you respect the other person and are willing to listen and enjoy them. And I think both he and I, if we share anything, it was the enjoyment of ideas and learning about the world, and we shared that tremendously.
I'm just curious. What was your position on the Iraq War? It's okay. You're among.
I knew everything I say is gonna bring up some news. I was not in favor of the Iraq War, and I think history has proven me right. But in any case,
Hitchens was for it.
Yeah, but yes, Hitchens was for it. The great thing about Christopher is you couldn't guess in advance. Like a lot of people, you'll know immediately what their view on something is going to be based on their politics. With Christopher, you could never tell, and I think that was another facet about him that was fascinating. So, and you can read about it. I mean, he wrote at great length about it. So,
here's a good little email. Let me toss this over in your court. Do you feel like there may be more to this universe that can be measured?
Yeah, absolutely.
Like ever.
Potentially ever. We have to realize when we're talking, and this is the kind of humility that a cosmologist has to have, and maybe they don't think we're very humble, but the point is we have to realize we're measuring one universe at one time, 13.72 billion years after the Big Bang, and we are limited in what we can see. And when it comes to a discussion of the whole universe, which is kind of amazing that we can even study it, there are fundamental limitations on what we may ever know, and we have to recognize that fact. There may be other universes that are causally disconnected from our own. We may never have evidence of them, and so we have to realize that we're bumping up on what may be the fundamental limits of empirical knowledge. We shouldn't be discouraged by that. We should keep pushing, but we should realize that we're limited by our time. As I pointed out, observers in the far, far future, hundreds of billions of years from now, will be limited in the fact that every galaxy outside our own that we now see will have disappeared. They'll find themselves empirically in a very different state than we are, and maybe we're in a very different state than we might have been if we had evolved, and I'm still allowed to say that word in the United States, if we had evolved 5 billion years earlier, or maybe 100 billion years in the future. And so I'm keenly aware, as my own work takes me to the limits of human knowledge, that what we may know may ultimately be constrained by limits on our ability to measure things. And that's okay. Just like I also know there may be no fundamental theory that, as Feynman once said, the world may be, nature may be like an onion where we peel back each layer, and every time we discover something new about the universe, there's another layer. That's okay. All we want to do is understand things. We're here for a while, and it's fun. There's pleasure in finding things out.
You know, when you take that little rectangle of paper and twist it and then join it together and you have the one-sided figure.
The Mobius strip, it's called, yeah.
It's called what?
A Mobius strip.
A Mobius strip, yes. Excellent. Let me ask you, this is just like way out of left field. Boom, here it comes, come without a warning like a UFO.
Good.
What are the chances that you can look backward in time? If we're looking out from here and we're seeing the past, is there a theory that addresses the reverse of this? Looking and see the future? No, looking back into the past.
Well, we are looking back in the past, not our own past. But when I look at it, when I take a picture of the Andromeda Galaxy, which is the nearest large galaxy to our own, it's about 2 million light years away. It looks just like the Milky Way, but that means the light from every star in that galaxy left that galaxy in order to get into my camera 2 million years ago. So I'm taking a picture of an object that's 2 million years old now. And so we are doing cosmic archaeology. We're looking at the past. We can't look back at our own past. Well, we can in some sense by our fossils and remnants. But the fascinating thing is that we're looking out at the past, and we take it. Some people find that surprising, but actually, it's just a mere fact that the speed of light is finite. So when I take a picture of a class, a line of 4 or 5 rows of the students in a classroom, and we take a picture, you think, well, that's the instant. They're all there the instant I took the picture, but that's not quite true, because the light from the people in the back of the classroom left them a fraction of a second before the light in the front of the classroom. So I'm really looking at a picture that's spread out in time as well as space.
Well, bringing that Mobius figure into play, is it possible to bend or twist time so that if we were there somehow, now I don't know how, but we'll address that later. We'll address that in a future conversation. I wonder if it would be possible to literally look back into our past beyond even the current moment.
Well, you're somewhat, in some sense, asking if we could. It's about time travel, and I've written about that. And it's fascinating that general relativity connects both space and time, and says that space is curved. And in principle, it allows for the possibility of universes in which have time travel in them, and which you could repeat the past. But we don't know. But first of all, there are strong constraints on what's possible as far as we know, and we don't know if time travel is possible. There are quite good reasons to think it isn't, but the equations of general relativity allow for that in principle, at least, and we have to understand it. I wrote one of my books, The Physics of Star Trek. I tried to explain that in great detail. The fact is, we cannot say at this point that time travel is impossible. It's unlikely, and as my friend Stephen Hawking used to say, to argue against it, that if time travel were possible, we'd all be inundated by tourists from the future. I countered him by saying they all went back to the 1960s and no one noticed.
Yeah, let's go look at the cavemen. That's very interesting. Well, we got 2 minutes here, and I want to ask a question that I'd like for you to amplify as much as you want. But I'm going to save it for when we come back. Now, if someone wants to get your book, let's just eat up a minute here.
Yeah, let's talk about the book. That's important.
Yes, let's do. First of all, where can they get it?
Well, they should be able to get it from every bookstore in the country, plus BarnesandNoble.com and Amazon.com, where it's doing very well, and I'm hoping that it will do better after this program.
Do you have your own site, your own blog, or anything?
Well, I have my own web page, which you can get it from as well. It will link to either of those booksellers. It's www.krauss, KRAUS.faculty.asu.edu. But if that's too long, just go to one of the booksellers or Google my name or Google A Universe from Nothing. My hope, once again, with the book is to use that question that interests everyone, including you, why is there something rather than nothing, as a hook to try and encourage people to learn about the fascinating and remarkable discoveries we made in the last 100 years and to celebrate them.
So you're tweaking us. I like it. I like it very much.
Okay.
We will continue our conversation with Dr. Lawrence M. Krauss and maybe even take a few of your calls if you would like to speak with him right here on the one and only Coast to Coast AM. Thank you very much, Ross. I like biting off more than I can chew because it's so good once you get it all chewed. Well, somebody suggested that I ask shorter questions, and the answer is no. I'm not going to do it. I'm going to ask the question as the question comes about, and that's just how it is because, as I stated earlier, no matter what you do, somebody's going to have a problem with it. Okay? And as far as this character, let me tell you something. You can send me any kind of an email you want, but the moment that it starts waxing moronic, it gets deleted. Now, I'm not talking to 99.999% of the listeners out there, but it's like, listen closer and reserve your opinion until you've heard it all. That way, your email will make some sense. In the meantime, hit me with some more of them. John B. at coasttocoastam.com. We shall return for the final hour, including your calls, with Dr. Lawrence M. Krauss, who wrote the book, A Universe from Nothing, on Coast to Coast AM. Dr. Krauss, I got a question for you. What are the chances of a state, not necessarily of existence, but just a state beyond the behind the veil of what we see? Our eyes are designed to see only certain frequencies. So somewhere in the area that we cannot see, no matter what kind of an instrument we use, what are the chances that something is there where neither space nor time exists? Or do these virtual particles that you mentioned earlier already exist in that state?
Well, there's certainly a great likelihood that there are things that you can't see. There's much more to the universe than meets the eye, and that's why we design detectors to be able to see lots of things you can't see, X-rays, infrared radiation. There's a whole universe of things that our eyes can't see. But the good thing is that we can design detectors to extend our own senses to be able to see them. We can't see the virtual particles that are there because the fundamental limits of physics tell us we can't measure time intervals so short as to see them. They exist by definition over time intervals that are too short to observe. But nevertheless, our notions of time and space at this point persist on those scales. It may be when we get to the smallest scales of nature, the scale where quantum mechanics and gravity have to come together, where we don't yet have a good theory. It may be that on that scale, the notions of space and time, as we now understand them, may have to be redefined or thrown out altogether. But at this point, for all the scales we can measure with our large accelerators, from the smallest scales we measure at the Large Hadron Collider to the largest scales we measure with the Hubble Space Telescope, say, the notions of space and time seem to work. But what is absolutely true, and what is so fascinating, is there's much more to the universe than meets the eye, and it's those very discoveries that I try and celebrate in the new book.
All right, very good. You know, a fellow, a fellow named Rush just sent an interesting email. I think it's interesting. Isn't it really, really smart of all those random particles of dust out there to first form an inner molten core of only uranium, iron, and nickel, then start adding the carbon and the silicon and aluminum and magnesium and all of this? I mean...
Well, what are they talking about? That's not the way the Earth formed, and it's certainly not the way the Sun forms. We understand these things. It's amazing how... And one of the things that I talk about in the book, which to me is one of the most poetic things in the universe, and something that I hope everyone will eventually understand, is that you are literally stardust. The atoms in your body came from stars that exploded, because it turns out in the Big Bang, the only elements that were created were hydrogen, which is basically just protons, helium, and lithium, and the important elements. Well, lithium may be important to some of your listeners, but the more important are carbon, nitrogen, oxygen, iron, and those are only created in the cores of stars. And the only way they could get into your body is if the stars were kind enough to explode. Stars explode about once every 100 years per galaxy. All those heavy elements were created in the nuclear furnaces inside of stars, and they're atoms in your left hand that come from different stars than your right hand. And I find that so cosmically inspiring, the notion that we are all stardust, and that every atom in our body has experienced one of the most violent cosmic explosions in nature. A supernova explosion is truly, truly remarkable, and something that's worth celebrating and telling your friends about.
Excellent. Would you like to take a call?
Sure, I'd love to.
Well, let's talk to Bill in West Hartford on the wild card line. Bill, come up on the bridge and talk with Dr. Krause.
Yes, hi, John. Hi. This is my first time talking to you, John, personally, and welcome to Saturday night.
Thank you very much.
Dr. Krause, hi. I'm an amateur astronomer and an atheist myself because I am an amateur astronomer, and I have two fantastic questions to ask you that relates to your book, which essentially says, why is there something other than nothing? I'll ask them together and then listen to your answer. Question number one, could something be another form or another aspect of nothing, and could nothing be another form or another aspect of something? Meaning, could nothing as well as something be different forms of the same thing? And question number two, which relates to biology but relates to what you're talking about, because I'm an atheist, Christ is the myth, and because my point is, the Virgin Mary in the myth had conception of some kind with supposedly God or the Holy Spirit. My point is, using biology, the egg of Mary, even though it's a myth, the egg of Mary is two X's, is a woman. You did not have a man with an X and a Y chromosome having sex with Mary. Therefore, the offspring of Mary, namely Jesus, if he existed, he would be a she. It would be a woman. And since Jesus has never been said to have been a woman, a female, he's supposedly a male, it cannot happen. A virgin birth has to produce only a female. Therefore,
Wow.
Jesus did not exist. As well as there were previous religions before Christianity where gods died for the believers and were crucified as well and went to heaven in 3 days also.
Oh, okay. Let's see. Let's take the first question first. In some sense, that it's a good question because in some sense, one of the points that I'm trying to describe in the book is that our definitions of something and nothing are very different than what people thought before. And yes, because something can turn into nothing, in some sense there's physical connections between them. Other people's nothing can easily turn into something, and therefore there are different versions, if you wish, of the same thing. A space with nothing in it versus a space with lots of stuff in it, combined with negative gravitational potential energy, can turn into one another. And of course, therefore, there's relationships between something and nothing, just like Einstein tells us energy and mass are related. I can take matter and turn it into radiation, and so they're related, even though they're very, very different. So yes, something and nothing are much more related than you'd think before, and that's why the question, why is there something rather than nothing, is really not only not the right question, perhaps, but not very surprising, because nothing often turns into something, as I describe in the book. So I think that absolutely the modern physics tells us we have to be much more careful with those notions, and those antiquated notions from philosophy and theology have to be thrown out and replaced by operational terms that are based on what we actually know about the universe. As far as your questions about Jesus and Mary and Christ, I mean, I don't view the Bible as a scientific document, and I don't worry. There are a host of contradictions if you take the doctrines literally, and I think I suspect most people take those things that they find difficult to swallow and throw them out. Most people don't. I think they adopt their theology to what their preferences are, and so I don't really feel the need to comment on the genetic problems associated with a virgin birth. There's never been a virgin birth anywhere else, and there's no evidence that there was one then, as much as anything else. So I don't take it seriously enough to actually worry about those particular contradictions, because there are a host of other contradictions.
All right. Alan, Hollywood, Wild 2. Are you there?
Hello, good evening, gentlemen.
Good
Hi.
evening.
Hello. I was just want to answer what you just said, that actually Krishna was born of a virgin also, if maybe you don't know that. But
Well, actually, in almost every religion, they have a story very similar to the myth of the birth of Christ. Yeah, it's nothing new. The Christians borrowed very heavily from earlier religions. Absolutely.
yes, and the concept of existence and non-existence, as you can see in battling, but in ancient Buddhist texts, and it's sort of a reflection. One is a reflection of the other. And I wanted to ask you, will we ever reach the outskirts of infinity?
Well, I don't make predictions about the future. We have gone much further than I would have ever imagined, even when I was a graduate student, and I suspect that in an infinite universe there will be things forever beyond our reach, but the universe surprises us. So I think what we can do is keep on traveling. I liken at the end of my book to the myth of Sisyphus. Camus' myth of Sisyphus, which Sisyphus was a Greek mythological character, doomed for eternity to roll a rock up a hill, and just before getting to the top, the rock would roll down the bottom, and he'd have to start over again. And Camus said, "I imagine Sisyphus is smiling," and I think so too. The search is worth the effort, even if the rock keeps rolling down the hill. I don't know if we'll get out there. We just got to keep trying.
All right. Thank you very much.
Thank you.
Thanks for the call. Greg in Muncie, Indiana. Are you there, sir?
Yes. Hi, John. Good show tonight. Dr. Krause, I have a couple quick questions for you, and I'll take your answers off the air. But my first question is, if quantum physics accepts the idea that a particle can exist in more than one place at the same time, why does the act of measuring that particle keep it from continuing in that state? And the other question I had is, what do you think about the research, I believe, out of the University of Arizona, claiming that the human brain is a quantum computer?
Yeah, okay. Those are both good questions. Well, the answer is that it depends on the nature of measurement. When you measure an electron to be and you see a dot on a cathode ray tube or a screen where the electron hits and causes it to fluoresce, then you've measured it at that point. It doesn't constrain its future motion. So there's certain measurements you can make that later on constrain completely the system to remain in that state. There are other measurements that don't. And so if I measure a particle at time t to be at point x, depending on the type of measurement, that doesn't tell me that later on it can't be once again in many different places at many different times. At that instant, I've constrained it to be there. But I don't constrain its future motion. So there are other configurations where if I measure an electron to be spinning in a certain direction in a magnetic field, I can once I've done it and once I preserve it and stop it from interacting with anything else, I do in some sense force it to be in that state. So it depends on the type of measurement you do. The way you constrain the future in quantum mechanics depends upon the type of measurement you do. Now, as far as this purported research from Arizona, I think it's nonsensical. I've briefly talked to one of the people who's not a physicist, who claims that somehow quantum mechanics allows things to happen, you to think of things before they happen, and I don't see any sense to it, and I know that they're interested in it, but I think it's a misunderstanding and a misapplication of quantum mechanics, and I certainly don't see that it's had any relevance or any impact on any other research. So I think it's just a red herring.
Well, all right. Let's see here. Someone asked a question a while ago that has the speed that these galaxies, I presume that these galaxies are also in some sort of a rotation or not?
Well, with each other?
Well, yeah, the same way that the planets orbit the sun.
Yeah, our galaxy orbits, our sun orbits around our galaxy once every 200 million years. Now, galaxies tend not to orbit around each other. They do. Certain galaxies are in bound systems. The motion tends to be a little more chaotic because there's enough of them that they're sort of moving around randomly. It isn't a nice smooth orbit. But our galaxy does the disk of our galaxy does an orbit about once every 200 million years, and our sun does that every 200 million years around our galaxy.
Has its speed been estimated?
Yeah, it's about 200 kilometers per second, and in miles, it's about 120 miles per second. It's traveling around our galaxy.
Okay, so it's nowhere near light speed.
No. Nowhere near light speed. The rotational speed is not anywhere near light speed, which is why we can often use sort of straightforward Newtonian arguments to try and understand it. Well, we don't get to light speeds until we talk about the expansion of the universe on the very largest scales.
Well, what's the speed of light again? 360,000 meters per second or something? What is it?
Well, it depends upon. I mean, in units that are probably relevant to most of the listeners, 186 million miles per second.
Okay, gotcha. Oh, is that all? That's pretty fast.
Yeah.
Okay, well, if one of these, let's just take a hypothetical, one of these galaxies or any galaxy managed to...
I've got to make sure I got that right because I always work in meters per second, but I'm pretty sure I got that right.
Understood.
Anyway, it's in meters. Let me just say it's 300 million meters per second. So that's the way to do it. So it's okay.
What's all this about a potential time reversal if the speed of light is met or exceeded? Is that still a viable theory?
Sorry, it's 186 million miles per hour now. I remember that conversion. But anyway, sorry. If in terms of time going backwards, if you go faster than light.
Yeah.
Well, in principle, that's true in the sense that different observer, if an object were traveling faster than light, different observers would observe that object. One observer might observe that object moving forward in time, but another would observe it moving backward in time. And that's one of the many reasons why real things we don't think move faster than light.
Does Einstein's theory still hold with current thinking?
Absolutely. It explains every observation we can make. Now, as you may have heard, there was a claim of an experiment in Geneva in Switzerland, the Large Hadron Collider, that claimed that potentially these particles called neutrinos were traveling faster than light from Geneva to a detector in a tunnel in Italy by 60 nanoseconds. Now the point is, it's most likely wrong because it tends to disagree with most other experiments, and there are many good reasons to think it could be wrong. It's a very complicated apparatus, and light travels. All you need is about 30 extra meters of cable that's not accounted for somewhere, and you can account for the 60 nanosecond delay in light versus neutrinos. So it's worth being very, very skeptical of that result. It's very, very unlikely to be correct. Of course, if it were, it'd be fascinating because but it's most likely incorrect. And people should realize that most experiments at the forefront, when we're at the limits of our sensitivity, come up with spurious results all the time because we're at the limits of our sensitivity. I like to say I'm pretty certain the experiment's wrong because nothing ever arrives early in Italy.
Right. Right. Listen, we're coming up on a hard break, but just Einstein's theory that there is no universal time, there are only local times, that still holds?
Yes. Time is observer dependent. Your clock depends upon where you are and what you're doing. Observer dependent. Yeah, in fact, if I'm at a slightly higher altitude or lower altitude than you, my clock is ticking at a different rate. Not enough that our clocks, neither your clock or mine is sensitive enough to measure it, but GPS detectors depend upon that every day. The satellites, you wouldn't be able to. I wrote an article once. You wouldn't be able to navigate your way around Los Angeles or wherever you are if we didn't use that fact of relativity, that the different satellites are at different altitudes and traveling at different speeds. We have to compensate for that fact to make it work. Excellent. Let's carry on. This has been a fast 2.5 hours, and we're going to come back with some more calls and more with Dr. Lawrence M. Krauss, A Universe from Nothing, when Coast to Coast AM continues. I'm on the outside looking inside, or are we on the inside looking outside, or are they one and the same? And what difference does it make anyway? It's all part of the journey, isn't it? The destination is the part I'm a little concerned about. We'll finish up our discussion this evening with, how about this morning, with Dr. Lawrence Krauss, a learned and rational man. He has his viewpoints on things, and you have yours. So if you'd like to share them, we will take as many of your calls as possible, and as much of a shameless promotion as this may seem to be, it isn't really shameless. It's something that I think that you will like, and that is to consider becoming a Coast Insider. 1,000 shows, 3 years worth of archive shows. You can listen to anytime you want, and it's very, very inexpensive and easily affordable. So consider becoming a member, and stay with us for our final segment on Coast to Coast AM. Dr. Krauss, James in Indiana has been holding on the line for a while. Let's see what kind of a question he has. James, come up on the bridge and talk to us.
Yes, hi.
Hi.
This is my first time caller. Can you hear me?
We'll be gentle. Yes, we can hear you. Go ahead.
All right. Is it okay if I ask two questions?
Hit me.
Sure.
Okay. My first one is this. When you were discussing the possibility and likely or unlikeliness of intelligent design, and you said how evolution was the natural occurrence of a process that happens in nature by itself. I was thinking, can't chaotic systems in actuality be engineered? Like AI learning programs or board games with cards that you draw or the double pendulum?
Well, okay. Well, I'll answer that question first if you want. Well, look, yeah, chaotic systems can be engineered, but the point is that if there's no evidence of engineering, then you don't have to. It's an extra assumption to assume it. And in this case, we understand perfectly well, given the way genetics works and the predictions we make based on evolutionary biology, agree with every observation we've ever made over 150 years of a process by which a distribution of a population with a distribution of genes can evolve in a natural way. So, yeah, there can always be something that sets that system up, but without evidence of that, it's an additional hypothesis that doesn't add anything.
Well, the only reason I mentioned that question was like somebody mentioned something to me once that stuck, and they compared humans to, say, angels. As far as intelligence go, how much we are smarter than a bird.
Well, sometimes we are, sometimes we're not, but yeah.
Well, sort of that comparison. No matter how many birds land in your backyard, you're still smarter than all of them combined.
Well, some of them can navigate around the world, and I couldn't. But I think the big difference is that birds exist, and as far as I can tell, angels don't. So.
Okay. And my other question is, since we cannot move or see or measure anything past the speed of light, which is why its limit seems constant to me, if we can't see past that, and you mentioned briefly about negative and positive energy, gravity and anti-gravity, how do we know that there aren't things as exotic as, say, particles or objects with negative masses out there whose rest mass is non-existent? They have to exceed the speed of light, whereby it would be just as difficult for them to slow down as it is for us, positive masses, to accelerate.
They're called tachyons. They're called tachyons in physics or in Star Trek. Well, the answer is, look, we can't rule out the possibility of things that might possibly exist. What we can say is there's no evidence that they do. We've searched in cosmic rays, and we get the most exotic particles from across the universe coming at us in cosmic rays, and we look for these kind of things. We look for faster-than-light particles. We look for particles with weird properties. We look for it not because we want to preserve the theories we have, but because we want to discover new things about nature. And there's no evidence of it. That's all we can say, is that there's no evidence that those things exist, and we scoured the universe looking for them. But we can't say that something we haven't yet seen doesn't exist unless it violates the laws of physics, and there are careful constraints on what might be possible for such tachyons, and we know the particles we measure in nature aren't that way, and so there are careful constraints. But of the particles, when we look for these kind of things, we haven't ever observed them in cosmic rays at accelerators or coming from anywhere in the universe. And so, once again, there's a lot we don't know about the universe. We have to recognize that fact. But there's a lot we do know, and the things that we've tested aren't going to be violated. We can't allow particles that violate the rules that already work because we've tested those rules. When it comes to the limits of what we know, of course, then much greater set of possibilities open up. But bottom line, once again, is we've no evidence that such things exist at this point, having scoured the universe looking for them.
All right, very good. Very good. Interesting questions and very interesting answers. Let's see. Who do we have here? West of the Rockies. Jack in California, out there somewhere in California. It's a big state. Don't know where you are in California, but come on up on the bridge and talk to us.
This is Jack in Willits, California.
All right.
And as I was waiting to get on, I scribbled something on the pad here. Believers are positive that they know something, that they know what is, and atheists are positive that they know what isn't. And the difference between those two is that believers have an abundance of faith and atheists have an abundance of hubris. Now, let me go on from that.
Hello?
Did we lose him?
I think he, we lost it. I'm happy to comment on that if you want.
Go ahead.
I think that true believers believe my problem with the thing is assuming the answer before you know the question. If you know what's right before you ask how things actually work, then your mind is forever going to be closed. So being absolutely certain that you possess the truth without ever having explored it is, I think, the ultimate hubris. I think most people who call themselves atheists are really saying they find the preponderance of the evidence to suggest to them that there's no God. You're right, it is hubris to say with absolute certainty that there's no purpose or intelligence behind the universe. But what you can say is, given what you know about the universe and the lack of such evidence, it's unlikely. And I think that's a reasonable statement. And as I say, I personally fall in that camp, and rather than to claim that I know everything about the universe.
Let's see, is that, am I seeing Larry in Jacksonville? LA Control, first-time caller?
Yes, you do.
Oh, come on board. How are you?
I'm great. First-time caller. Love the show. I love you, Guy. You're amazing. But I have a quick comment and a question. My comment is to the doctor, based off of your words that the Bible was written by illiterate peasants, wouldn't it be highly unlikely that they could somehow write one of the most famous books in the entire world and sell it? Well, they wouldn't sell it, but people would sell it, and it would be one of the biggest books ever if there wasn't some sort of divine intervention. I mean, it wouldn't make really any sense if there was nothing from nothing, and all of a sudden this fake book by illiterate peasants could be written, and it could sell to just about everyone in the world.
Well, I think the point is that religion is deeply based in human culture, and people really want to believe. So, how the sociology and history of how certain beliefs are held is remarkable, and it goes in different societies. The fact that societies believed in Zeus or Thor or Odin for periods longer than our society has been around in some cases is remarkable, and we now look at those beliefs and say, well, those are quaint, but they didn't have it right. And I'm not. So I think it's it's not surprising that certain religious beliefs and certain things that are written down get followers because people want to believe. Just because something's popular doesn't make it right. And sometimes when I look at the books that are popularly written and sell a lot, I often wonder about that. And so I think it's not the Bible. The fact that it's got a lot of adherents is remarkable, and same with the Quran. And it is a property of the human psyche that people want to believe and coalesce around certain beliefs. But it's happened throughout human history for beliefs which are completely mutually inconsistent, for gods that are completely mutually inconsistent. So it's fascinating. I agree with you, but I don't think it points to anything fundamental.
All right. Let's see. Michael. Let's see. Yes. Michael in Virginia, east of the Rockies. Come on board.
Thank you so much. Lawrence Krauss, Dr. Lawrence Krauss. I remember you many years ago on this program with Art Bell when he was interviewing. Is that correct?
That's correct. I go way back. Mm-hmm.
Yeah, way back. And in fact, I still have those programs, or that one program at least. What I like about you is the fact that you like Christopher Hitchens. He always impressed me from the very first time I heard him. The greatest political debater I ever heard. I would never miss him if I heard he was on. I would stop anything I was doing to hear Christopher Hitchens.
I agree with you.
Your theory I just want to test it a little bit because I agree with you too about the problems with religion. But if we have a God who really doesn't care, which you suggested would be the only kind of God that you want.
No, I don't even want that kind of God. But anyway, go on.
You wouldn't even want a God who doesn't care about you?
Yeah, I don't care about it. I'd rather have nothing at all. Yeah.
Okay. Well, if you'd rather have nothing at all, I don't know why you said you'd rather have a God that.
Well, I'd rather have a God that didn't care than a God that cared, but I'd rather have no God at all than a God that. Anyway, it's semantics. Let's move on.
Okay. So if the second best God that you would choose is one that doesn't care at all, I'm wondering what your application of that attitude would be towards other human beings. Would you rather live in a world where no human being cares about another human being?
Absolutely not.
Well,
but I don't see. I mean, look, there's no logical connection between the two. I observe other human beings, and I care about other human beings, and I observe them. I don't observe a God. I don't observe a universe that has any such characteristics, and I also wouldn't want to live in a world, I suppose, where all the frogs in the world were watching me. I don't see the connection.
Ken in Seattle. Oh, sorry to cut him off, but let's get with Ken in Seattle because we're running very short on time. Thanks for the call, pal.
Mm-hmm. Dr. Krause, am I on?
Hi.
You are.
Okay. I just wanted to bring up that it seems to me that a lot of people have a problem where they believe that when people talk about evolution or planetary development or cosmic development, that means randomness and random mutation when it comes to evolution.
You're right.
And I think they're taking out of context a term, random mutation.
Absolutely.
And that's only one kind of mutation. When you're passing your genes from generation to generation, you've got a kind of deliberate mutation that's impacted by your parents' genetics and the environment that they live in, and the environment that you grow up in affects your genetics as you develop. And people have a problem when they try to debate against atheists as if there should be a debate. I don't think there should be. But when they do, they're always saying, well, how can randomness explain the complexity of an eyeball? How can randomness explain this? How can it explain that? No one's trying to say that I know of that randomness explains any of this.
Absolutely. Evolution is anything but random. I mean, that's the whole point. It's when you have natural selection, a system is driven to in a certain direction. And you're absolutely right. I mean, the word mutation, randomness, goes about in part of the process, but the process itself is anything but random. And you're absolutely right. Those people who argue that having a human being is like having all these parts of a 747 in a junkyard and the wind blows and produces a 747 just don't understand the fact that evolution and natural selection is anything but a random process. You're right.
Excellent.
Very long periods of time, and
very, very long periods of time.
Hundreds of millions of years, and how many generations, let's say with humans, how many generations that entails as we developed. And I also wanted to bring up that searching for life, I think people need, out in the universe, people need to kind of differentiate between searching for life versus searching for intelligent life.
Absolutely.
Versus searching for any life whatsoever. Because, for instance, if we were to run across a planet at some point where the most intelligent life that we could identify with would be equivalent to Native Americans of 300 or 400 years ago, I think that would be basically the same thing as finding mirror images of ourselves, but they wouldn't be transmitting any radio signals out into space.
Absolutely. I mean, if your point is well taken, I've written about this. I mean, even if intelligent life exists, the likelihood of detecting it is extremely small. If someone told someone on a distant star to look for life on Earth, and that civilization had been around for 5 billion years, during most of the history of the life on Earth, they would have no evidence of intelligence. Only the last few years, since we've been emitting radio waves, would they detect us. So it's going to be extremely difficult to find intelligent life, even if it exists. As opposed to life, I suspect we'll find evidence for at least fossilized life on other planets in our solar system, perhaps Mars or the oceans of some of the moons of Jupiter, etc. But it's going to be it's a long slog, and I guess the point to say is that not having heard anything does not mean it's not there. It's just a big universe, very difficult to detect, and civilizations may exist for only a short time during those periods. And so you're absolutely right. The odds are against it. I would argue. I suspect it's unlikely, even if intelligence exists elsewhere in the universe, that we'll ever know about it. But once again, it's still worth listening.
Chris in South Korea, come on real quick. You got about 1 minute.
Hello, can you hear me?
Yep.
Yes, sir.
Okay, thank you very much. You have a very interesting show tonight.
Thank you.
Yeah, I just wanted to bring up the fact that we spent most of the night talking about Western religion versus science, and of course, because we're Westerners. But I wanted you to talk a little bit about Eastern philosophy, and specifically Taoism and its relation to physics, and I'll take that off the air.
Okay, thanks. Well, I mean, you're right. We tend to be a little myopic when we're talking about it. Look, there's been I think there are fascinating aspects of various aspects of Eastern religion and some people have overstated the connections between Taoism and physics, and there have even been books written on that I think overstate those connections. I think to the extent that the statements are vague, one can often find concurrence between some of those statements and some of the statements in physics, but I think that's largely, frankly, accidental. To the extent that they don't involve a creator, but involve observations of nature, I think there's obviously concurrence.
We got to go.
Anyway, okay.
I hate to tell you this. We have to do this again sometime. Dr. Lawrence M. Krauss, thank you very, very much for staying with us for these 3 hours. But we've got to bail. It sure has been a pleasure. It's been a lot of fun. Thanks to our guests tonight, James Childs and Dr. Lawrence Krauss, George Norrie, Lisa Lyon, George Knapp, Ian, Rob, and the L.A. crew, and especially you, the best listeners on this or any other planet, and I do mean from all over the planet. Until next Saturday night, this is John B. Wells saying, you be well too.